Now let's discuss the very important topic of this chapter, that is rationalization. So what are we going to do in this kind of sums? Basically, we are going to have questions something like this in the form of fraction, and you will be seeing that in the denominator there is some square root, right? Maybe it's possible that only one term has the square root, or maybe two terms, or maybe both of them, or you have the whole number. We'll discuss the variation, you'll have an idea, right? So how to deal with this kind of problems, right? We are going to use all the knowledge that we use so far for the operations on the irrational number, like identities as well, maybe product as well, right? So let's discuss how to do this question. We need to find the conjugate of this one. So how do we find it? Just change the middle sign, right? Let me show you how to do that. Here we have 3 plus root 2. So I will be taking 3 minus root 2. Done. And we are supposed to multiply this one. So remember, we cannot just multiply anything. So we multiply in a manner, right, that it will cancel out each other. So whatever is there in denominator, same should be there in the numerator. That is 3 minus root 2. Okay. See, the numbers are same only. 3 here, so 3 as well. Root 2, so root 2 as well. But only middle sign is changed. Plus, so we have written minus over here. And the same term should be there in the numerator as well. So if you want to do cancellation, yes, you can do cancellation, and this is going to remain as it is. Simple. Now let's discuss the second step. As it is the multiplication, let's write here bracket. As it is the multiplication, obviously we are going to do what? Multiplication. So let's start here. 1 into anything is going to remain as it is. That is 3 minus root 2. But in case of denominator, see, 3 plus root 2, let's write here 3 plus root 2, and here 3 minus root 2. So if you observe, this is of the form a plus b, and a minus b form. So what's the solution for that identity? Sorry, that is a square minus b square, right? So same we are going to write numerator as it is, that is 3 minus root 2, and denominator we can write that is 3 square minus root 2 square. Let's simplify further. So 3 minus root 2 over here square of 3, that is what? 9 here, and square root of 2, that is what? 2 only. So we have 3 minus square root of 2 over 7. Now see what we did over here, rationalizing, right? So initially we had this square root in the denominator, but right now we are not having it. So we are done with the sum, right? How we approach this question? First of all, find the conjugate, that is 3 plus root 2. So conjugate will be what? 3 minus root 2. Just change the plus to the minus. Multiply in numerator and denominator. Same, right? That being done, now the operation is normal only. Numerator multiply with numerator, denominator with denominator. But remember always, denominator, we are always going to apply this identity. This is the idea behind multiplying with the conjugate. So we always need to apply the identity into denominator. Now simplify further and get the answer. Let's discuss the next question. So we have here 4 by root 7 plus root 3. Now here also we are going to approach in the same manner. First of all, we are going to find the conjugate. So here root 7 plus root 3. So what we can write? Let's write multiplication sign, and here plus. So we'll be writing root 7 minus root 3. Now same will be in the numerator. Understand this first step very importantly. It's very easy as well, right? You need to write the same terms with the, you need to just change the sign, plus, so minus, and exactly same should be there in the numerator. That being done, now let's multiply. So let's start with the multiplication. 4 into this, so let's write 4 into square root of 7 minus square root of 3. Right now let's just write in this manner. And denominator, like I told you, see, this is a plus b, a minus b, right? So far we have written something like this, but if you want to write directly, you can write it. That is, let's write square root of 7 and whole square minus square root of 3 and whole square as well. So here we have 4 into square root of 7 minus square root of 3. Done. Now let's do the square over here. So here it will not be 49, but it is what? 7, and here that is 3. So let's subtract further. 4 square root of 7 minus square root of 3, and denominator 7 minus 3 is what? 4. Now see, 4 and 4 in get cancelled. So here we have only square root of 7 minus square root of 3. Very simple it is, right? So this is how we rationalize the denominator. Remember this step, most important step is the first step. You write the exactly same numbers, you have plus but you write minus over here. Exactly same should be written in the numerator. Then start multiplying numerator with numerator, and denominator we are supposed to apply this identity. So you do the square of them and minus sign in the middle. Keep simplifying and get the answer. Now let's discuss next question. Let's discuss the sum related to negative sign. So this is where it is. Let's start. Square root of 6 over square root of 3 minus square root of 2. So we are supposed to start with the conjugate. So let's start. We'll multiply here obviously, and we'll write the same numbers first of all. Square root of 3, square root of 2. Now here it is minus. So what we'll be writing in this case? Plus. Now exactly same number should be there in the numerator. Root 3 plus root 2. Done? Simple. This is how we do for the negative sign. Now let's start with the product we are supposed to multiply. So here square root of 6 and in bracket 3 plus square root of 2. That being done, let's talk about the denominators, that is a minus b and a plus b forms. So I told you we can write here, let's write square root of 3 whole square minus square root of 2, then square as well. Let's multiply into the numerator. So root 6 into root 3, that is what? Root 18 minus root 6 into root plus here root 6 into root 2, that is root 12 over here, and in denominator here that is 3 and here that is minus 2. Now 18 is over there. Okay, let's just first of all write in this way, square root of 18 plus square root of 12. Done, and denominator 1 will be there, so I'm not writing it, doesn't make any sense. We can write here that is 1 only. Now 18, we need to simplify. This is composite number. Can we write this 18 in the factors of perfect square? Let's try to think of it. Yes, it is what? 9 2s plus 12 we can write as 4 3s, right? So square root of 9 is what? 3, and here square root of 2 as it is, plus here square root of 4 is what? 2, and square root of 3 as it is. Simple, right? So this is just for the negative sign. Steps are going to remain same. You write the same numbers here but change the sign, minus, so plus, and exactly same terms should be there into the numerator. That being done, find the product, numerator with numerator, denominator with denominator. Denominator we apply the identity, numerator you can multiply it. Simplify numerator and denominator both. Here we see that we have the composite number, so let's simplify further. We discussed this kind of questions, how to simplify it, right? So this is how we do for the negative sign. Let's discuss one more question over here. So let's start with the question that 1 by 2 root 5 minus root 3. So how to rationalize the denominator in this case? It is same as the previous one only, nothing much to do. So let's start. First of all, here let's write the same terms, 2 root 5 and root 3. As this is minus, we will be writing here positive. Now exactly same two terms into the numerator, 2 root 5 plus root 3. Done. Now let's multiply numerator with the numerator. So 1 only, it is going to remain as it is, plus here root 3, and denominator will be applying the identity. So here we will be writing 2 root 5 and square minus root 3 and square as well. So numerator is going to remain as it is, that is 2 root 5 plus root 3, and here square of 2, that is what? 4, and square of square root of 5, that is what? 5 only, minus, in this case we can directly write 3. So let's simplify further. We have 2 square root of 5 plus square root of 3. Here 4 5s are 20 minus 3. So we have 2 square root of 5 plus square root of 3 and denominator 17, right? Simple, right? So this is how we deal with the negative sign as well. We just need to make sure that how we write the conjugate properly, then multiply numerator with the numerator, denominator we apply the identity only. Be careful while you simplify the denominator. Now let's discuss more questions. Let's discuss one more question. Let's start with the question. Here root 3 plus root 2 over root 3 minus root 2. So first step is going to remain same. Let's start with the first step. So we are going to find the product obviously, and here numbers root 3 and root 2 as it is minus over here we'll write plus. Now exactly same should be there into numerator, right? Don't think that it is matching or not, that's not our concern. Okay, now let's start with the product. So if you see into the numerator, we can write square root of 3 plus square root of 2 and whole square over here, and denominator we can simply write square root of 3 whole square minus square root of 2 here square as well. So we can apply the identity directly, right? A plus b whole square. So let's start here root 3 and square as it is plus, so plus 2 then root 3 and root 2 plus here root 2 whole square, done. And denominator here root 3 whole square, so that is 3 minus 2 only. Now 3 minus 2 answer we know very well, that's what? 1, like the previous case. Here let's write the numerator. Here it is 3 plus 2 and square root of 3 into 2, that is what? 6 plus square root of 2 square, that is 2 only. Now 3 plus 2, that is 5 plus 2 root 6. Very simple, right? We discussed this case because we have the two terms in the numerator, that's first time. So this is how we solve in this case. First of all, start with the denominator, take the conjugate root 3 and root 2 as it is minus, then plus over here exactly two terms into the numerator. Then see, if we observe that in numerator we can apply the identity a plus b whole square, so apply that identity, apply the identity in denominator as usual, that is root 3 square minus root 2 square, simplify further and get the answer. Let's discuss one more question. So here we have, let's say, root 3 plus 1 over 2 root 2 minus root 3. Okay, so this is the question. So we are going to start with what? Conjugate only. So let's start with the multiplication. First of all, here 2 root 2, so here as well, then root 3, so root 3 as well. As this is minus, we'll be writing plus, so 2 root 2 plus root 3 exactly as the denominator. Okay, now let's start with the multiplication. Here we have root 3 plus 1 and 2 root 2 plus root 3. So here in numerator there is no identity like the previous one, so we need to find the product. And denominator we can write 2 root 2 square minus root 3 square. Let's start with the numerator. We need to find the product. So root 3 multiply with the whole bracket, so root 3 and 2 root 2 then plus root 3, then here plus 1, then the whole bracket, that is 2 root 2 plus root 3. Remember, that's why we learn about the product of the binomial, right? We need to apply that concept over here. Denominator identity only, square of 2 that is 4 and square of root 2 that is 2 only, minus here 3. Then let's simplify the numerator. Root 3 into 2 root 2, that is what? 2 into root 6. Then let's multiply further. Root 3 into root 3, that is what? Plus 3 only. Now anything multiply with 1 going to remain what? Same only. So 2 root 2 plus here root 3. Done. And denominator 4 2s are 8. 8 minus 3, that is 5. So we can write here as the 1 by 5 as well, that can work out. Now 2 root 6 plus 3 plus 2 root 2 plus root 3. We are not able to find any kind of like terms over here, so we need to keep as it is. That's it, right? That's what we were doing in the product as well. So That's it. Let's write 2 root 6 plus here let's write 2 root 2 plus root 3, and finally let's write 3 over here. So this is how we solve when we have the two terms in the numerator as well, right? This is that case only. Here we have the denominator 2 root 2, not only single irrational number that so far we discussed about. Remember the method, it is same. You take the conjugate of the denominator 2 root 2, numbers are same, change the sign, exactly same terms in the numerator, then start multiplying numerator with numerator, denominator identity always. Then here in this case we apply the identity because we were able to find that we observe that a plus b whole square, so we apply the identity. But here is not the case. In that case you need to find the product, right? Then simplify further. So this is how we solve the sum. Now let's discuss different kind of question related to rationalizing the denominator. We have this equation, we need to find the value of a and b, right? See, square root of 5 plus square root of 3, root 5 minus root 3 is equal to a plus b root 15. We need to find the value of a and b. First of all, don't think much, right? That will use some kind of logic over here. Ignore this RHS for a while and solve it as the rationalizing the denominator. So that's what we are going to do. Let's write here root 5 plus root 3 over root 5 minus root 3. Now rationalizing, right? So conjugate here, let's write the denominator, that is exactly same, root 5 and root 3, but different sign here, minus, so we will write plus, and exactly same into the numerator, root 5 plus root 3. That being done, now let's multiply, find the product. Here we can see root 5 plus root 3, root 5 plus root 3, so identity, root 5 plus root 3 here whole square, and denominator root 5 square minus root 3 square, identity right here as well. So let's simplify here a square, so we will write root 5 square, then plus, then 2ab, so root 5 and root 3 plus root 3 whole square, and denominator here we have 5 minus here, that is 3. So let's simplify further. Here we have 5 plus 2 root 15. See, 2 root 15 plus here, that is 3 only, and denominator we have 2. Let's simplify further. So here 5 and 3, that is going to make what? 8, plus here we have 2 root 15 and denominator 2 over here. So let's divide individually. So here let's divide individually. 8 by 2 plus 2 root 15 by 2 over here. Here 2 ones are and 4s are, 2 and 2 get cancelled. So what's left? 4 plus root 15. Now compare with the question. What do we want to find? We want to find the value of a and b, and it is given in the form a plus b root 15, right? So we know value of a is what? 4 only. But what about b? There's nothing over here. Remember, if there is nothing, we write what? 1. So finally we can write that a is equal to 4 and b is equal to 1. Very simple question. Just the extension of what we were already doing. Rationalize the denominator, that's what we did. And finally, just compare with what is given into the question. It is possible, negative answers are also possible, right? So this is how we find the value of a and b.